Okay, so in this lesson, we're going to look at the addition property of equality, and part one is where we're going to actually use this addition property, and this is going to help us to solve equations. And we're going to be dealing with what's called linear equations. All right, but let's kind of review something from a previous lesson. So remember, an expression is a combination of operations on variables and numbers, and an equation is where you have an equal sign. And so basically it's of this form where you have some expression equal to another expression. So an expression, remember, has no equal sign. An equation has an equal sign. So here's some examples. So for example, this is an equation because you have these two expressions. On the left side you have 2x minus 1. On the right side you have 6, and they're equal to each other, so that's an equation. This is just an expression because there's no equal sign. And notice a variable here is x. Now here, here's an equation, 7 plus 3 equals 3 plus 7. Although there's no variable there, it's still called an equation because you have this expression and you have this expression, and we're saying they're equal to each other. Here, this is not an equation because there's no equal sign, but it's an expression. And in this case, it has parentheses, and so you're going to see later on in another section, or the lesson rather, that you're going to have to use a distributive property. Okay, so over here, again, you have an expression on both sides, and there's equal signs, so that's an equation. Notice that the variables on both sides, so you're going to learn some properties that's going to help you to solve this equation. So the idea in all of these will be, in this lesson, will be to solve equations. It won't be this difficult in this lesson, but at some point you will learn how to do this. And this is an expression. This is x cubed. And over here we have this equation. Notice the parentheses, so at some point we would need to use the distributive property. And notice that over here, this is just an expression because there's no equal sign. All right, so these were examples of equations and expressions. Now, in a previous lesson, we discussed determining if a number was a solution to an equation. So, for example, so the question is 6 a solution to the following? Because here's the first one. So remember we did to help us determine if 6 is a solution. And so the idea in this lesson will be to find these solutions. So here they're asking, is 6 though a solution? So again, to determine if it's a solution, and remember this was from a previous lesson, where we see the variable x, you would substitute 6. So in other words, you would say, all right, here's the variable x, so I say 3 times x, so that's 3 times 6 minus 4, and I want to see if that's equal to 18. That's the question. So are these two sides equal to each other? Well, let's focus on this side, because this side there's only one number there, so there's nothing really to do. That's going to be 18. So using the order of operations, we have 6 times 3 is 18, and then 18 minus 4 is 14. And so notice that 14 does not equal to 18. So 6, so this is no, so 6 is not a solution. Okay, so again, so wherever you see the variable x, you would substitute 6 in this case. Okay, so let's look at this next example, part B. All right, so there's my equation, 2x plus 1 is equal to x plus 7. So where we see the variable x, and I see it on both sides, I need to substitute 6. All right, so here we go. So we're going to say 2 times 6 plus 1, and I want to see if that's going to equal, notice a question mark here, if that's going to equal 6 plus 7. So where we see the variable x, I'm substituting 6. Okay, so let's focus on the left side for right now. So using the order of operations, I have multiplication and addition. So remember we do multiplication first. So that's 12 plus 1, and then 12 plus 1 is 13. Over here, we just have 6 plus 7, and that's 13 as well. So are they equal? The answer is yes. So that means that 6 is a solution. Okay, so that was a review of the idea of what a solution is from a previous lesson. Okay, now, so this 6 that we saw, let me go ahead and write it here. So the 6 that we saw here, so the 6 is a solution, not here rather, the 6 is a solution here because it makes both sides of the equal sign equal to each other. So it makes this expression equal to this expression. Okay? 6 is not a solution here because this side we saw was 14 and it's not equal to 18. Okay, so a value of the variable that makes an equation a true statement is called a solution or a root. So notice that sometimes we'll use the word solution, sometimes we'll use the word root. They mean the same thing. Okay, the process of finding solution of an equation is called solving the equation for the variable. So you're going to learn a process to do this. So the process of finding the solution of an equation is called solving the equation for the variable. In this section, we'll focus on linear equations. Most of the course will be focused on linear equations and inequalities. In the next course, you're going to have different types of equations and inequalities, but here we're going to focus mainly on linear equations. Okay, so let's talk about the definition of a linear equation. So a linear equation in one variable, we're only dealing with one variable right now, has this form. So you can write it in the form ax plus b equals c. All right, now notice, oh, by the way, a, b, and c can be any real number, but a cannot equal 0. So a can be 0 because if a is 0, notice 0 times x is 0, and so the variable goes away. All right, so that's why a cannot be 0. But I want you to notice is this, the variable x, the exponent's 1 right here. So the exponent's 1. So that's important. So in another course, the variable would be other than 1, so it would no longer be linear. So it's linear because the variable is 1, and it has this form, ax plus b equals c. All right, now, okay, so let's talk about the idea of solving a linear equation. So to solve a linear equation in x, we write a series of simple equations. So you're going to see this in a little while. So we write a series of simple equations, and they're all equivalent to the original. They're equivalent to the original equation, so that the final equation has this form. And so this really is going to, you're really going to see this in the next lesson or the lesson after that. But it has this form. So your final step will be x equals some number, or you could say some number equal x, but at least it will be x equal a number. So it'll look like this. It will be something like x equal 5. Okay, it will look like this. Okay? All right. So what are equivalent equations? Well, equivalent equations are equations that have the same solution. And this means that the number above, so this number right here that we're referring to, this number above, is a solution to the original. And so as we get into more complicated equations, you're going to see that each of those steps that follow are called equivalent equations, because whatever that number is will be a solution to all of them, but in particular it will be a solution to the original, which is what you're trying to find a solution of. All right, and then the first property, okay, so let's start talking about these properties. The first property of equality that helps us write simpler equivalent equations is called the addition property of equality. The addition property of equality. All right, so let's talk about the addition property of equality. All right, the addition property of equality. Okay, before we do that, let's kind of see what the idea will be. So we all know that 3 equals 2 plus 1. Okay, so just think of this as a balanced scale. But if I add 5 to this left side, to keep it balanced, I've got to add 5 to the right side. So basically what this says is, what we just saw here is that if I add, or I could have subtracted, I could have said 3 minus 5, or subtract a number from one side of the equation, I have to do the same thing to the other. Okay? Now you have to do the same thing to the other. So if I add 6 here, I got to add 6 here. If I subtract 1 here, I got to subtract 1 here. Okay, you got to keep this equation balanced. So it's like a balance scale. All right, so let's talk about the addition property of equality in terms of the definition. Okay, so we're going to let A, B, and C represent numbers. Okay, so those are going to represent numbers. If A equals B, so let's suppose that I have this equation. On the left side we have A, on the right side we have B. Okay, then if I add C to the left side, then I have to add C to the right side. So basically that's what this says right here. So if I add C to one side, I've got to add C to the other. And basically those two equations here are equivalent. So these are equivalent equations. Equivalent equations. Okay? Now, let's do this again. But notice though, now even though it's called the addition property, Notice though, if I subtract C, so if A equals B, then A minus C must equal B minus C. So if I subtract C here, I got to subtract C here. Okay? All right. Now, again, these are equivalent equations. So this equation is equivalent to this equation. All right. Now, it's not called this idea here is not called the subtraction property of equality. There's only addition property of equality. We can subtract because remember subtraction, we can always change subtraction to addition. All right, so we may subtract the number. We may subtract the number from both sides. Since subtraction is defined in terms of addition. All right, so remember from a previous course where you had something like 7 subtract 9. So what you learned in the previous course was that I can always change subtraction to an addition problem. And when I do that, I got to use that phrase, add the opposite. All right, so I'm going to read this again. So when you read this, this is a positive 7 subtract a positive 9. Positive 7 subtract a positive 9. So I can always change subtraction to addition, but I got to add the opposite. So this says 7 plus, and then the opposite of a positive 9 is a negative 9. And so that's what this says. Subtraction is defined in terms of addition. So I can rewrite subtraction as addition problem. So these two are equivalent. So this and this are equivalent. Okay, equivalent expressions. And these are not equations, these are expressions. This expression is equal to this expression. These are equations because this side equals that side. Okay, so those are equations, but they're equivalent expressions. All right, so that's why it's still called the addition property. It's not called the subtraction property, it's called the addition property. There is no subtraction property. It's just the addition property of equality. All right, so let's look at some examples. All right, suppose now, so all we're going to focus right here is the addition property. All right, so directions will say solve. Okay, number 1. All right, suppose we had x minus 2 equal 6. X minus 2 equals 6. All right, now you can guess at the answer here, all right, but you are going to have to show the work. So the answer here is 8 because 8 subtract 2 is 6, okay? But let's think about the addition property. So what I have here, I'm going to do it the long way, so watch this carefully. So x minus 2, I'm going to leave some space here, leave some space right here. All right, so I'm trying to get the variable x by itself. All right, so right now I'm subtracting 2. So if I want to get x by itself, I've got to add something to this negative 2 to get a 0 here, to cancel it out. So I got to get just an x. So the opposite of subtracting 2 is to add 2. But what I do to the left side, I've got to do to the right side. Okay? Now remember in a previous lesson where we combined like terms. So a negative 2 and a positive 2 is 0. Remember that's just 0 here. So I'm left with x equal, and then 6 plus 2 is 8. Okay? Now what some students do, I'm going to go ahead and rewrite this again. Rather than writing it horizontally like this, what some of them do is this. Okay, they'll write it vertically. So I got to get x by itself. So right now I'm subtracting 2. So I'm going to use the addition property of equality. So I'm going to think of the opposite. What's the opposite of subtracting 2? The opposite of subtracting 2 is to add 2. So I'm going to add 2 to both sides. Notice this is the same thing as this. It's just that this is written horizontally, this is written vertically, and I'm combining the like terms. So when I combine like terms, a negative 2 and a positive 2, that's what this is. A negative 2 and a positive 2, that's 0. And then x and a 0 is still x, and then 6 plus 2 is 8. Okay? All right, so you can do any approach. I normally just use this right here. Number 2. Suppose we had x plus 5 equal, let's say, 7. X plus 5 equal 7. Okay, so right now, remember we're trying to get the variable x by itself. So I'm going to use the addition property of equality. So the addition property of equality says I can add or subtract a number from both sides of the equation. So think of the opposite. What right now I'm adding 5 to x. The opposite is to subtract 5. So I'm going to subtract 5 from both sides. Again, what you do to one side, you have to do the other. So notice have subtract 5 here, and I have subtract 5 on the right side. And now combine like terms. 5 subtract 5 is 0, and so I get x to equal 2. And so notice I want to talk about, so that's your solution here. So that's your solution. So x equal 8 is your solution. X equal 2 solution, because 2 plus 5 is 7. 7 equals 7. Notice I want to talk about equivalent equations. So remember, this was the original. That was the original. I'm going to write it horizontally for you. So this is the horizontal one right here. Okay, and then we got x equal 2. So all of these equations are equivalent. So all these equations are equivalent. These are equivalent equations because each of these equations have the solution 2. So 2 equals 2. 2 plus 5 minus 5 equals 7 minus 5. And then 2 plus 5 equals 7. 7 equals 7. Okay? All right, number 3. Suppose we had this. All right, suppose we had x plus 1.8 equals 0. Let's say 5. X plus 1.8 equals 0.5. All right, so we have a decimal, so use your calculator if you need to. So right now, remember, I'm trying to get x by itself, so I'm going to use the addition property of equality. All we're focused on here is the addition property of equality. That's it. That's all we're dealing with. In the next lesson, we'll look at something else. So right now, the opposite of adding 1.8 is to subtract 1.8, but I got to do to both sides. What I do to the left, I do to the right. So notice subtract 1.8, subtract 1.8. You got to say subtract. You have to say subtract. You have to say right here, you got to say add. You must show the symbol. All right? So it is wrong to do this. Okay, this is wrong. I'm going to show you right now what some of you are going to do. You're going to say 2, 2. Well, what about this 2? You got to, this is not correct. You must say plus 2, plus 2. Okay? So make sure you're very careful with how you show your work so you can get full credit. All right. So let's go back here. So notice the opposite of adding 1.8 is to subtract 1.8. So notice I'm saying subtract 1.8. Subtract 1.8. What I do to the left, I do to the right. Now let's combine like terms. So positive 1.8 and negative 1.8, remember those are opposites. We talked about opposites in a previous lesson. Those are opposites. So when I add them up, I get 0. So x plus 0 is still x. And then using a calculator, so we're going to say 0.5, 0.5, and then I'm subtracting 1.8, and I get negative 1.3. So x equals negative 1.3. So there's your solution. And you can check it if you want to check. Go back to the original. It's easy to check these because it's just one little step. So when I plug in negative 1.8, so the question is negative 1.3 rather. Negative 1.3 plus 1.8, the question is that equal to 0.5? Well, use your calculator. Negative 1.3, right? I have it in there. Plus 1.8 equals 0.5. So this is 0.5, and they are equal. Okay? They are equal to each other. So that's your solution. All right, let's look at this one. So let's suppose we had number 4. Suppose we had t, that's t minus 7.6 equal a negative, let's say, that's fine, 9.2. All right, so t minus 7.6 equals a negative 9.2. All right, so notice, remember, I'm trying to get the variable t by itself. So that's the easy kind. These are the easy kinds right here because there's just a t here and it's just on one side. And then in another lesson, you're going to have variables on both sides. But in this case, it's just on one side. Okay, so right now I'm subtracting 7.6. The opposite of subtracting 7.6 is to add 7.6. I'm going to add 7.6 to both sides. And then combine like terms. So these are opposites, so that's when I add them up, I get 0. And I'm left with just t right here, equal. And then use a calculator, and negative 9.2 plus 7.6 equal, and then that's a negative 1.6. So I get at t equals negative 1.6. So that's your solution. And you can check if you want to. Okay, on a test you will not have time to check, but you can on a worksheet because you do have time for that. So let's check. So in place of t, I'm going to substitute negative 1.6. Remember, you're asking, is this a solution? That's from a previous lesson where we see the variable t, you substitute negative 1.6. And so let's see. Let's see what that equals. So is that equal to negative 9.2? That's a question. So I'm going to say negative 1.6. So negative 1.6. Subtract 7.6. Look how it looks. Negative 1.6 subtract 7.6 equal, and I get negative 9.2. And that's what I wanted. Okay, so they are equal. All right, now let's look at this. Okay, suppose you had this. Suppose you had, this is going to be number 5. Suppose you had 7 equals, let's say, negative 4 plus x. So 7 equals negative 4 plus x. All right, and that one's going to be a little bit challenging for you. So I got to remind you about something. So remember, this is addition, right? So addition is commutative. So for some of you, if it was this, let's say it was this. I'm going to write this as 6. We're going to look at 5 and 6 together. So 7 equals 4 plus x. So notice the difference. This one's a negative 4. This one's a positive 4. I think for the most part, all of you should be able to get this pretty easily. So to get x by itself, right now I'm adding 4. See how it says this, adding 4? So the opposite of adding 4 is to subtract 4. Okay? All right? And so 4 subtract 4 is 0, combine like terms, and 7 subtract 4 is 3. So I get x equal 3. And it kind of makes sense because if I check it, 4 plus 3 equals 7. Okay? But I want you to notice as well is this. See where I had 7 equals 4 plus x? Let's look at this still. Remember, addition is commutative. The order in which you add does not matter. Remember, this is addition. So addition is commutative. So what you're going to see is that 7 is the same thing as saying x plus 4. And so for some people, it is easier to solve an equation if the variable is listed first. So see right now, it kind of looks like the others that we're doing. See, the variable's listed first, the variable's listed first, variable's listed first. You didn't have to rewrite it, but if you need to, go ahead and do so. Just be careful though, especially with this. All right, so I'm going to subtract 4, and I get the same thing. 4 subtract 4 is 0, x plus 0 is x, equal 7 subtract 4 is 3. All right, let's look at this now. Okay, so let's think of it in a couple of ways. So here this says I'm adding a negative 4 to x. All right, and so the question is, you got to think about this. If you put something down, see if it makes sense. All right, so I'm adding a negative 4. What's the opposite of adding a negative 4? Adding a positive 4. Okay, so think of that way. Adding a positive 4. I'm adding a negative 4. The opposite is to add a positive 4. So I'm going to add 4 to both sides. And so when I combine like terms, a negative 4 plus 4 is 0. 0 plus x is x. And 7 plus 4 is 11. And I can check. Let's check this. Let's check. So 7 equal, the question is that equal to negative 4 plus, and I'm saying x is 11, remember? All right, on your calculator, check, see what negative 4 plus 11 is. So negative 4 plus 11 equal, and you get 7. What I want you to notice, though, let's use this idea with this. Okay, so I'm going to come back. I'm going to rewrite this over. I'm going to show you another way in which you could think about this. And this is true because this is addition, okay? This is only true because that's addition right here. So remember, addition is commutative. So the order in which you add does not matter. So instead of saying negative 4 plus x, I could say x plus a negative 4. Okay? But that's the same thing right here. That's the same thing as saying x minus 4. So x minus 4 is the same thing as saying x plus a negative 4. And now, notice I'm subtracting x. The opposite of subtracting x is to, I'm subtracting 4. The opposite of subtracting 4 is to add 4. And so now combine like terms. These add up to be 0. 7 plus 4 is 11. So I get x to be 11. Okay? So the way in which you do these does not matter as long as it's logically correct. Okay? All right, so that takes care of 5 and 6. Now let's do one with a fraction. All right, this would be number 7. Number 7. All right, suppose we had this. Suppose we had y minus, let's say, 5/8 equals, and let's say this is 7/4. So y minus 5/8 equals 7/4. Okay, so just like we did in the previous lesson, right now I'm subtracting 5.8. The opposite is to add 5.8. So I'm going to add 5.8, I'm sorry, 5/8, excuse me, 5/8. So I'm adding 5/8 to both sides. All right, so opposites, these are opposites, so that's 0. Y and 0 is y, equal. All right, so here I have 7/4 plus 5/8. So you got to do some work. 7/4 plus 5/8. Now, we saw how to use a calculator, so if you got to use a calculator, remember how to do that. You're going to say 7 divided by 4 plus 5 divided by 8 equal, and you get this decimal. Okay, so remember how to do that, how to change this decimal back to a fraction. So you're going to say second, PRB, so that remember how you get this fraction to decimal. Say equal, and you get this mixed number. So this right here is 2 3/8. That's what it is. But then you got to remember that I've got to change this back to an improper fraction. Don't leave it as 2 3/8. Write it as an improper fraction. So you can say 8 times 2 is 16, and 16 plus 3 is 16, 17, 18, 19 over 8. So 7/4 plus 5/8 is 19/8. So this is 19/8. Okay? All right. Now, let's do this a long way. So suppose you didn't have a calculator. So you got to find the LCD. Let's kind of review that. So the LCD, what's the smallest number that 4 and 8 go into? Well, it's 8. So the LCD is 8. The LCD here is 8. So I'm going to write two fractions with that denominator. And I'm going to write equivalent fractions. 7/4 is equivalent to what fraction with this denominator? That's the question. So remember what we did. We said 4 times 2 gives us this 8, but what I do to the denominator, I got to do to the numerator. 7 times 2 is 14. This right here, these are already 8s. The denominator is already 8, so that means that 5/8 is equivalent to itself. So the numerators have to be equal to each other. And then notice that 14 plus 5 is 19, and that's 8. Okay? All right, now if you want to check, here's the way I would check this. You have access to a calculator. So wherever you see the y, you're going to substitute this number because that's what you're saying the solution is. So 19/8 subtract 5/8, and the question is that equal to 7/4? That's your question. So in a calculator, just do this real quick. You don't have time to really do all this work. So you're going to say 19 divided by 8 subtract 5 divided by 8 equal, and you get this decimal, 1.375. Okay? So this is 1.375. Over here, 7 divided by 4, notice that's 1.75. All right, so let's see what I did. 19/8 minus 5/8, and we see that's 7/4. So let me do this again, because notice this says 1.75, so something's wrong. 19 divided by 8 minus 5 divided by 8 equal, okay, I'm not sure what I did, but that's 1.75. And this is also 1.75, and so they're equal. All right, so let's look at another. Let's do one more with a fraction. All right, suppose we had this. Suppose we had c plus, let's say, 2/7 equals, let's say, 5/14. All right, so c plus 2/7 equals 5/14. So right now I'm adding 2/7, so I got to get c by itself. I got to solve for c. So the opposite of adding 2/7 is to subtract 2/7. So subtract 2/7, just like this. Combine like terms. A positive 2/7 and a negative 2/7 is 0. So c plus 0 is c. And on your calculator, you're going to say 5/14 subtract 2/7. That's what you're going to say. So you're going to say 5/14 subtract 2/7 equal, and you get this decimal. So let's convert that back to a fraction, and we get 1/14. So this is 1/14. So the answer is 1/14. Okay. Now let's do this a long way. So the smallest number that 14 and 7 go into is 14. So the LCD is 14. These fractions are these denominators are the same. So 5/14 is equivalent to itself. So the numerators have to be equal. Here I'm going to say 7 times 2, 2 times 2, and so 2 times 2 is 4. And then 5 minus 4 is 1, so I get 1/14. And that's what I got here. Okay? All right, so, all right, what if you had this? Let me just kind of do this real quick. What if I had, let's say, 2/3 equals x plus, let's say, 1/4. 2/3 equals x plus 1/4. All right, so right now I'm adding 1/4 to x. The opposite of adding 1/4 to x is to subtract 1/4. So I'm going to subtract 1/4. And so combine like terms, 1/4 minus 1/4, that's 0, because they're opposites. And then x and a 0 is still x, equal. So I got to figure out what 2/3 minus 1/4 is. So using a calculator, 2/3 minus 1/4, 2 divided by 3 minus 1 divided by 4 equal, I get this decimal. Converting it back to a fraction, I get that's just 5/12. So I get 5/12. So x is 5/12. All right, now the long way, when I say the long way, I mean if you don't have access to a calculator, you have to write equivalent fractions. So the smallest number that 3 and 4 go into is 12. And so you're going to write equivalent fractions. 2/3 is equivalent to what fraction with this denominator? So 3 times 4 is 12. So 2 times 4, what I do to the denominator, do to the numerator. 2 times 4 is 8. Over here, 4 times 3 is 12. Again, what I do to the denominator, I do to the numerator. 1 times 3 is 3. And so 8 subtract 3 is 5, and I get 5/12. Okay? All right, so that was the lesson on using the addition property of equality. So the next lesson, we'll get a little bit more detail into solving these kinds of equations that we saw earlier. So at some point, you're going to eventually solve these kinds right here. Right here. Okay? All right, so that takes care of this lesson.